Okay, so in this section, we're going to talk a little bit about some common feature engineering options in Python. In the last section, just as a quick review, we talked about what features are, what feature engineering means, and some common reasons for needing to do feature engineering. In this section, I've pulled out a few things that are most common ways to do feature engineering in Python. It's not every possible way that you could do some sort of feature engineering in Python, but these are the things that seem to be most common, at least in my experience and from what you see others using. So let's go ahead and get started. I'm going to go over what we're going to be talking about over here, and then on the left, after we've gone through this initial list, we'll do some examples. Okay, so most of your data munging and feature engineering will happen using the Pandas library. Pandas is a great library that we've talked about before, and it really makes feature engineering and data munging much easier in Python, and it's one of the reasons, and that capability, building that capability is probably one of the reasons that Python is having such growth in the data science field. Before Pandas really hit its stride, there just wasn't a very good solution for data munging in the way that data scientists and analysts need to do it in Python. So with that said, each of these things except for list comprehension are pandas functions. We'll start with apply. Apply is a good generic solution. It's useful for numeric features primarily, and it can be used on single features, so a single column at a time, or it can be used on multiple features, multiple columns at a time. There's one gotcha that I want to just give you a heads up about, and it's not probably going to make too much sense right at the moment, but you'll see it when we do the examples, I believe. It takes an access parameter, and with that access parameter, you can tell it whether you want to apply a function that you've written row-wise or column-wise. I should step back and say what apply actually does is it applies some sort of function, some sort of custom function that you've written, and that custom function is what actually does the data manipulation, what actually creates the new variable or feature that you're trying to create. So we'll go through that in a minute and you'll be able to see how that works. But that access parameter is something to watch out for. All right, the other thing that is commonly used is map. Map is good for string or labeled data because it takes a dictionary. And so if you've just got a few labels, let's say less than 10 or 15 or 20, then it's pretty straightforward to even manually type those in. If you've got a dictionary that is created dynamically, it's sort of irrelevant how many key and value pairs you have up to a certain extent, of course, so you start getting into performance issues. Another option for doing feature engineering is list comprehensions. This is a very Pythonic way to do things. And it's useful, you'll see, for simple matching of simple searching, like if you want to look for a subset of text or if you want to look for a specific numeric value. And it's also good if you're looking for if you want to do just like a simple if-else branch to create a new feature. These are things where apply and a custom function may be overkill. So list comprehensions are a good, simple Pythonic way to do that. Now there are two other things here that kind of get honorable mention. They're beyond the scope of what we're going to talk about today, but that's the groupby and ag functions. Now groupby and ag are good for creating features that summarize the data. That's essentially what they're built to do. And they're really useful functions, and they're so useful that they deserve their own video. I would rather set them off to the side and come back and do them later than try to cram them into this. And the three things that I've mentioned here so far will get you a really long way if you're new to Python and pandas. And then we'll come back and talk about groupby and ag later. Okay, so we've gone through that list. Let's jump over here to PyCharm and see some examples. So the first thing that we're going to do, as we often do, is import pandas. That's really the only library that we're going to be using right now. And the next thing that we need to do if we're going to run some examples is have some data. We need to get some data. So a great source of toy data is the University of California at Irvine's machine learning repository. They've got a ton of data sets here that are really fun to play with. They've got, and you can even filter by the types of features that you're looking for. So I've decided a good data set for what we're trying to go through today, it would be the abalone data, and you can get it from here. And Pandas makes it really easy to pull the data from an online source. It makes it really easy to pull it from a lot of places, but we can simply put in the URL and the column names, run read CSV, and it has the URL, so it knows where to go look for it, and boom, it'll take just a second, and there you go. We've got our sea snails abalone data in our snails object. Okay, we're going to convert that to CSV just so we have it around. Oh, no, I'm not. This is what happens when you pull down a repository and don't run it before you do a video. Let's see, do I need that later? Okay, and so now we're just going to copy that to CSV because we'll need it later on. You can see that I've highlighted the line I'm getting ready to run. Control Enter, run that, and we're good. Sorry, Shift Enter is what I've mapped that to. All right, and now let's just take a look at the data. We're going to run snails.head to see the top of it. Let's see that we've got sex, length, diameter, some physical information about the abalone, and some information that can be used to tell how old it is. The age of an abalone, as it turns out, is the number of rings it has when you count its shell, plus 1.5. We'll come back to that in just a second, but here's the describe. You just look through that. This is mainly in there for if you're running this from the repository. You've pulled it down yourself. This will just help give you a little look at the data. Not something we need to spend a lot of time on right at the moment. But as I mentioned, the age of an abalone snail is the number of rings it has plus 1.5 years. So here is where the feature engineering happens. Now this is a very basic one, but what we're doing is we're taking our previous data, the number of rings that each snail has, and we're adding a scalar to it, and we're creating an age based on that. And so we're creating a new variable, a new feature named age, from this previous feature called rings. So we do that, and as you would expect, that's created a new column. Called age, and you can see there that age is just rings plus 1.5. Okay, so hey, we've just done some feature engineering. That was pretty amazing, huh? Okay, but as it says here, that's about as easy as it gets. Let's say we wanted to do something more complicated, like take this age grouping and split it into things like young, middle-aged, and old. Okay, and here we're going to define young as anything younger than 9.5 years, and anything older than 12.5 years is old, and then anything in the between is middle age. So as I mentioned when I was going over the applied description before, what we need to do is create a function that we will use to we'll do the branching within the function, and we'll return values within the function, and then we will apply this function to our series that we want to apply it to, and we will, or to put it another way, we'll apply it to the feature that we want to apply it to, and then that will create our new feature. So just to step through this here again as I run it, this is our function, our custom function that we're going to write that will actually do the branching and return values as we want it to. And you can see here that it's called create age categories. We're going to pass it this parameter x. That x is going to be the series that we want to use as the basis for the feature engineering. And we're saying if the value of x is less than 9.5, return a string of young. If that's not the case, and the value of x is over 12.5, return a value of old. And then if neither of those apply, return a value of middle-aged. Okay, so we've defined the function, and here is the syntax that you'll want to use. You'll see that we've got the data frame, and the feature or the column, just like we would normally call them. And then we've added the apply method, and we're passing the function that we just created above. And so we're essentially saying apply this function, this custom function, to the age series. Okay? And when we do that, we'll be able to see that we have this new, here, let's do it like this. We have this new well, if I could spell, that would be helpful. We've got this new feature that is a string based on the feature that we previously created that represents the age. Okay, so one reason you might want to recode something from a numeric to a string, for example, is to make it is for visualization purposes. Maybe you want to be able to, in your charts, you want to be able to color by whether they're young, old, or middle-aged. And so when you label them in the legend, you want that to be easily apparent. So it's more helpful to have a string representation than a numeric range or a numeric representation. Okay, but let's say that our algorithm actually needs the categories expressed as integers. So maybe we're doing some sort of multiple value classification. So we've got 3 categories and we want to do some prediction to determine which of these 3 categories the abalone falls into based on some other information we know about it. And our software or our language or our algorithm only uses integers. It can't deal with the strings that we just created. Okay, that's fine. We can have the best of both worlds. We can create the strings and we can also create integer representations for them. So we can use the integer representations in the algorithm and we can use the string representations in our visualizations. And it's a great opportunity to show you how map works. As I mentioned before, map, you pass a dictionary to it, and so what that implies is that you'll first need to create a dictionary. So we're going to be working off of our categorical age feature that we just created, and it has values, as you recall, of young, middle-aged, and old. And so what we're going to do is create a dictionary that maps keys and values. Young is going to be 1. Middle-aged, we want to recode or feature engineer in our new feature to 2. 3, or old is 3. Alright, so we create this dictionary, age to int. Okay, and then the map method looks syntactically a lot like how you would use apply. So we're going to do the same thing. We've got our data frame, the series that we want to apply to, the map call, and then our dictionary that we're going to pass it. And so when we run that, see that we now have an integer representation of our strings before. Okay, so what we did, as you recall there, we created a new numerical feature, then we created a new string feature, and then we mapped that new string feature to a new integer feature. So we've created 3 things across 3 different steps here. But with apply, as I mentioned as I was first discussing this, you can do one series at a time, or you can do multiple series, multiple feature creations at a time. So the way that you would do multiple things is you pass the entire data set to apply, and you write a function that works across that within the function you call the columns that you want to call. And here we'll do that real quick. Yes, this is why I did this. Now I remember. We're gonna call that CSV that we created back, because that's original before we changed anything with it. We're going to start with a clean data set, and we're going to write a little function that creates both categories, both age categories, just like we ended up with after the last run. So as part of creating, here I'll show you, as part of creating both age categories, we create the age. Again, doing the same thing here, recoding it to young if it's less than 9.5, but we're also creating the categorical age integer value of 1. And then when we get down here, we're creating that directly on the data set that we've passed. And so when we get, and right now that's in the function scope obviously, so when we get down here, we'll output that data frame and we'll just overwrite the current data frame object, or we don't have to overwrite it, but we could overwrite it or we could create it as a new data frame to pull it out of the function scope and actually make it something that we can work with generally. Alright, so data frame, apply the function that we want to run, and then the axis that we want it to work on. I don't know if I ran this already, so let me go ahead and run it. Okay. Alright, now we should have snails method 2. And there you go. We can see that we got all the same features created, but we were able to do it by just passing the data frame to apply and writing our custom function to work on that data frame that gets passed and then output it. Alright. A quick little check here to show you that those are exactly the same. Snails is the data frame that we created using the manual steps. Snails method 2 is what we just did, applying across the whole data frame, and you can see that the test shows that they are true. So let's talk quickly about one more thing, one more way to do this, and that's list comprehensions. As I mentioned when I was talking about this early on, list comprehensions are good for doing, for creating binary classifications. They're good for doing things that involve simple logic and that might be overkill for a full-on custom definition of a function and then applying it across the data set or across a series. So just to quickly run through how that works, I've got a list comprehension here. This says return 1 if x, the value that we pass it, is greater than 12.5. Otherwise, return 0. Do that for every value x in the snails.age or the snails age series. Okay, so let's run that really quickly. You can see that we should have now a new feature that is an indicator of whether the snail is old or not. Okay, so let's go ahead and wrap up there. This is a good stopping point. We'll come back in a minute and talk about performance for some of these options. Performance is something that a lot of times you don't have to worry about, but it's good to have an idea of what works best in certain situations when you do.